Good morning students, welcome back to chemistry class. Today we are going to study about redox reaction and oxidation number. Okay, so last class we completed a limiting reagent and today we are going to study about redox reaction and oxidation number. Okay students, listen carefully, take notes. Okay, so redox reactions. Redox here, red indicates reduction. Okay, OX indicates oxidation. This means, so redox reactions means both oxidation and reduction, reaction takes place simultaneously. Both a reduction and oxidation reaction takes place simultaneously. This is called a redox reaction. For example, when an apple is cut, it turns brown after some times. Do you know the reason behind this color change? It is because of a chemical reaction called oxidation. Okay, so oxidation means so the oxygen from the air, it reacts with the apple, it becomes the brown color. Understood? So we come across the oxidation reactions in our daily life. For example, burning of LPG burning, it is oxidation. Okay, so LPG gas, when we are opening the LPG gas, so when we are burning the cylinder here, the LPG, it reacts with oxygen to form a fire. Okay, burning of LPG, oxidation, rusting of iron, it forms a rust because the oxidation. Okay, slowly oxidation takes place in iron, it becomes a rusting of iron. Understood? And another one example, redox reaction, oxidation reaction example, oxidation of carbohydrates, lipids, etc. into carbohydrates, carbon dioxide and water. Okay, when carbohydrates oxidation, we get carbon dioxide and water to produce energy in the living organism. Okay, carbohydrate, when we are eating carbohydrates, it converts carbon dioxide and water to produce energy in the living organism. Okay, understood? So these are the example for the oxidation. Okay, so both oxidation and a reduction reaction takes place simultaneously in a same reaction, that is called a redox reaction. Both oxidation and a reduction takes place in the same reaction simultaneously, that is called a redox reaction. Okay, so here what is oxidation, what is a reduction? Okay, what is oxidation? What is a reduction? According to the classical concept, oxidation means addition of oxygen. Okay, or a removal of hydrogen. That is called oxidation. Oxidation means addition of oxygen or a removal of hydrogen. What do you mean by reduction? The reverse of the oxidation called a reduction. What is the reverse? Oxidation means addition of oxygen or removal of hydrogen. A reduction means addition of hydrogen or a removal of oxygen. Okay, oxidation means addition of oxygen or a removal of hydrogen. That is called oxidation. What do you mean by oxidation? Addition of oxygen or removal of hydrogen. Okay, so what do you mean by reduction? Addition of hydrogen or removal of oxygen. Addition of hydrogen or removal of oxygen. That is called a reduction. Understood? So these are about the oxidation and the reduction. some example. And another one, concept, according to electronic concept of oxidation and reduction. Another one definition are having for the oxidation and reduction according to electronic concept. According to classical concepts, oxidation means addition of oxygen or removal of hydrogen. Reduction means addition of hydrogen or removal of oxygen, according to classical concept. According to electronic concept, oxidation means a loss of electrons. Loss of electrons. Reduction means gain of electrons. Reduction means gain of electrons. These are the important definitions about as oxidation and reduction. Understood? So one of the example, explain with an example. Consider one of the reaction, that is Fe, iron, that is the forming of rust. How the rust is formed, that is Fe, when iron, it reacts with oxygen, okay, to form Fe2O3. What is the formula for rust? This is important for the one more question. Rust, Fe2O3, iron oxide. Okay, so reaction of iron with oxygen, iron, that is Fe, when combined to oxygen, that is O2, to form Fe2O3. Okay, so we have to balance the equation here. Here 3 oxygen are having, but here only 2 oxygen. So to balancing the equation only, we are adding 3 oxygen only. We can balance the equation. So 3 2s are 6. So we have to make here 2. Okay, so 2 3s are 6. Here our reactant side also 3 2s are 6 oxygen. So iron, here only 1 iron, 1 mole, but here 2 2s are 4 iron. So we have to make here 4. Understood? So this is oxidation reaction. So what is the definition we are using here? Addition of oxygen. And another one, reaction 2, when hydrogen sulfide, hydrogen sulfide formula, you know, H2S, hydrogen sulfide, H2S, when it reacts with the chlorine to form hydrochloric acid. The hydrogen from the hydrogen sulfide react with the chlorine to form hydrochloric acid, HCl, plus sulfur. Okay, here we have to balance the equation here. Hydrogen here 2, H2S, hydrogen 2 atoms, so we have to make here 2 moles. Sulfur here 1, here also 1. Chlorine here 2, here also 2. Okay, so in this reaction, which reaction takes place here? Oxidation or reduction? Oxidation. Okay, so here which definition we are using here? Removal of hydrogen. The hydrogen from the H2S removed. Okay, removal of hydrogen. Understood? So what do you mean by, so in these 2 reactions, oxidation is called. In these 2 reaction, which type of reaction takes place here? Oxidation. Oxidation according as per the classical concept. Okay, understood? So oxidation in the reaction 1, oxidation takes place by the addition of oxygen. In the case of second reaction, oxidation takes place by the removal of hydrogen. Removal of hydrogen. So oxidation means addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen. Understood? So this is the definition 1. And second, what do you mean by reduction? Reduction means, you know, removal of oxygen or addition of hydrogen. Removal of oxygen or addition of hydrogen, that is called a reduction. Okay, one of the example, one of the reaction, consider one of the reaction, cupric oxide. Cupric oxide, CuO. What is the formula for cupric oxide? CuO. When it combines with the carbon to form copper, plus carbon monoxide. Okay, cupric oxide CuO when it combines with carbon to form copper plus CO. Here, which type of reaction takes place? A reduction. Okay, why it is a reduction? Because the cupric oxide is converted to copper by removing one of the oxygen. Okay, so removal of oxygen means a reduction. Addition of oxygen means oxidation. Understand? And another one concept, addition of removal of hydrogen means oxidation. Addition of hydrogen means a reduction. Okay, so here removal of oxygen, that is, so it is called a reduction. And another one, addition of hydrogen. For example, sulfur. When sulfur combines with the hydrogen, sulfur combines with hydrogen to form hydrogen sulfide. Here, what is the definition we are using here? Addition of hydrogen. Addition of hydrogen to the sulfur. Okay, so in this reaction, cupric oxide plus copper to form copper plus carbon monoxide means removal of oxygen. Removal of oxygen from the cupric oxide. So it is a reduction. In this another one reaction, sulfur plus hydrogen means addition of hydrogen to the sulfur. So it is the reduction. Understand? So this is the definitions for the oxidation and the reduction. And oxidation reduction reactions, that is redox reactions, are not always associated with oxygen or hydrogen. In such cases, the process can be explained on the basis of electrons. In such cases, the process can be explained on the basis of electrons. The reaction involving loss of loss of electron in termed oxidation and gain of electrons in termed reduction. Okay, so another one definition, already I told you, according to electronic concept of oxidation and reduction. What do you mean by oxidation? Loss of electrons means oxidation. What do you mean by reduction? Gain of electrons means reduction. Understand? One of the example, I will explain one example. For example, Fe2 plus. Fe2 plus, it is converted to Fe3 plus E minus. Okay, Fe2 plus gives Fe3 plus E minus. Understood? So here, which type of reaction takes place? Oxidation. Why it is oxidation? Because here, you know, the plus charge indicates the deficiency of electron. Okay. So Fe2 plus, it lost one electron to form a Fe3 plus. One more electron deficient here. So Fe3 plus. Okay, understand. And another one definition, that is, what do you mean by reduction? According to electronic concept, what do you mean by reduction? Reduction means, gain of electrons. For example, copper 2 plus. Copper 2 plus, when it gain 2 electrons to form copper. Okay, so copper 2 plus, it accepts 2 electrons to form copper. So here, which type of reaction takes place here? A reduction. What do you mean by reduction according to electronic concept? Gain of electron. Gain of electron is called a reduction. Understood? So redox reactions can be better explained by using oxidation number. Okay, so another one topic we are going to study about oxidation and number. Okay, so what do you mean by oxidation? Oxidation means, according to classical concept, addition of oxygen or removal of hydrogen. The reduction means addition of hydrogen and the removal of oxygen. That is called a reduction. According to electronic concept, what do you mean by oxidation and what do you mean by reduction? Loss of electrons means oxidation. Gain of electrons means reduction. According to electronic concept. Don't forget it. Okay. Students, then we are going to study about oxidation number. What do you mean by oxidation number? Oxidation number or oxidation state, it is defined as the imaginary charge left on the atom when all other atoms of the compound have been removed in their usual oxidation state. Okay, so if you want to prepare, if you want to know, if you want to find out the oxidation number, we should follow set of rules. Okay, we should follow set of rules. Then only we can easily we can calculate the oxidation state or oxidation number of an element in the compound. Okay, so what is the first rule? First rule, the elements is uncombined state. Okay, so the oxidation state of a free element. Oxidation state of free element. What do you mean by free element? Free element means the element in its uncombined state. That is the free state, free element. Okay, so for example, hydrogen, H2, chlorine, Cl2, Na, sodium, acid, sulfur. Okay, these are the uncombined state. These elements are in free state. Okay, understand. So in this case, here oxidation state of these elements are 0. Okay, these elements are in free state, oxidation state is 0. Understood. And what is the second rule? The second rule, all alkali metals oxidation state or oxidation number is +1. Okay, so here alkali metals, what are the alkali metals having? Sodium, potassium, rubidium, cesium, strontium, radium. These are the alkali metals. So all the alkali metals, the oxidation state is +1. Okay, but it is in combined state. Okay, we can relate the first rule. First rule, the elements in uncombined state or it is in free state. The oxidation state of sodium or any other element in free state, oxidation state is oxidation state is 0. Okay, so when the elements, these elements, when it is combined state, what is the oxidation state here? +1. It is combined. For example, sodium combined with chlorine. Okay, so here what is the oxidation state of sodium is +1. Understand? Okay, so because the sodium, one of the only one outermost electron having this one outermost electron, chlorine get this one electron. Okay, so we have the alkali metals are in +1 oxidation state. And then fourth point. The fourth point is when we are taking alkaline earth metal means the oxidation state is +2. For example, what are the alkaline earth metals? Second group elements we call as the alkaline earth metal. What are the elements? Beryllium, magnesium, aluminium, silicon, phosphorus, sulfur, oxygen, chlorine, potassium. These are the alkaline earth metals. Okay, understood. So this alkaline earth metals or what are the oxidation state? +2 oxidation state. Alkali metal +1 oxidation state. Alkaline earth metal +2 oxidation state. Understood. This is the fourth rule. And according to fifth rule, the fifth rule is hydrogen. So hydrogen is the non-metal. Okay, so hydrogen, it is a non-metal. So hydrogen is compared with a non-metal. The oxidation state is +1. Okay, when hydrogen is combined in non-metals, okay, for example, hydrochloric acid, HCl. HCl means hydrogen combines with the chlorine. Okay, here the oxidation state of hydrogen is +1. Okay, because hydrogen lost one electron to the chlorine. Okay, so here what is the oxidation state of hydrogen in the case of combined with a non-metal? +1. Okay, this is the fifth rule. What about the sixth rule? The fluorine. Okay, one of the there is The what is the sixth point means hydrogen, it is in combined with the metals means what is the oxidation state of hydrogen? -1. Okay, so students, I should understand the rules. What I told, the rules you have to understand. Then only you can easily calculate the oxidation state. Okay, so these are the rules, common rules. Okay, what are the rules? First, the elements in uncombined state, that is in free state, all the elements are in oxidation state 0. Second point, alkali metals oxidation state +1. What is third point? Alkaline earth metal oxidation state +2. Okay. And fourth point, the hydrogen. Hydrogen is the non-metal. Hydrogen when combined with a non-metal, oxidation state of hydrogen is +1. Suppose hydrogen is compared with the metals, for example, lithium hydride, LiH. Okay, here what is the oxidation state of hydrogen here? -1. Understand? And next point, the fluorine. Okay, fluorine has an oxidation state of -1 in all its compound. Fluorine has the oxidation state of -1. Okay, fluorine has an oxidation state of -1. Okay, and next point, the oxidation state of oxygen is in most compounds -2. Exceptions are peroxides, superoxides, and the compounds with the fluorine. Okay, then we are going to study about oxygen. What is the oxidation state of oxygen? Always oxidation state of oxygen is -2. -2. Remember, always oxidation state of oxygen is -2. But some cases, some exceptions are there. What are the exceptions? Important. I have to understand this. What is the oxidation? What are the exceptions or of the oxidation state of oxygen? Okay, usually oxidation state of oxygen is -2, but some exceptions are having. What are the exceptions? First one, when water, the oxygen, water means H2O. Okay, in water H2O. Okay, H2O. So in water, the oxidation state of oxygen is -2. -2. Because hydrogen, hydrogen oxidation state +1. 2 hydrogen having, so 2 hydrogen, for the 2 hydrogen, 2 oxidation state of hydrogen is +2. Okay, so when oxidation state of -2 only, the charge will be neutralized. Okay, so in water, the oxidation state of oxygen is -2. And next case, in hydrogen peroxide H2O2, it is in -2. The hydrogen, in hydrogen peroxide, the oxidation state of oxygen is -2. -2. Okay, understand? -1. For example, H2O2, hydrogen, we have to calculate the oxidation state of oxygen here, H2O2. Hydrogen, what is the oxidation state of hydrogen? +1. Okay, so 2 into +1 plus what is the oxidation state of oxygen? We don't know what is the oxidation state. So here how much atoms are having? 2 oxygen atoms. So 2 into X is equal to 0. Okay, so the 2X is equal to when this 2 plus 1, 2 into 1, 2. Okay, so it is when it come after the equal to, so here +1 +2, it will be changes to -2. Okay, understand? So X is equal to -2 by 2 -1. Okay, understand? So here in case of hydrogen peroxide, the oxidation state of oxygen is -1. Understood? And the next one of the exceptions, what is the third exceptions? In superoxides. In superoxides, such what are the superoxides? Potassium oxide is one of the superoxide. For important for the 1 mark question, which one is the superoxide? Potassium oxide is the superoxide. Here the oxidation state of potassium oxidation of oxygen in oxidation state of oxygen is potassium oxide dioxide minus half is the oxidation state of oxygen in KO2 -2, sorry, -1/2. Okay, -1/2. Because potassium oxidation state, we know potassium is alkaline matter. So here oxidation state of the potassium is +1. Okay, +1 plus 2x. 2 into x, we know, don't know x. X is equal to 0. Okay, so x is equal to so 2x is equal to -1, so x is equal to -half. Okay, so in oxygen in difluoride, in the case of oxygen difluoride, that is OF2, the oxidation state of oxygen is +2 here, +2. Okay, how it is +2? Because we can, how to prepare the oxidation state, which elements we want to prepare, we have to take as x plus fluorine. What is the oxidation state of fluorine? Fluorine addition -1. Here 2 fluorine atoms are having, so 2 into -1 is equal to 0. So x is equal to +2. Okay, so these are about the oxidation number and how to calculate the oxidation number using one of the using the rule. We have to tomorrow we can study clearly. Okay, and okay students, today our assignment write 5 rules to write the oxidation state.